Okay, folks, we're on another journey together, and this journey is going to be a very, very, very long one. And the reason that I say that is because we're getting ready to talk about carbonyls, and there's so many different types of carbonyls that we're going to break it up into three parts, and we're going to call it Type I, Type II, and Type 3. Don't give any points to creativity here, folks. We're talking about scientists. We're not talking about English majors and that kind of thing, right? I mean, no creative skills typically come along with this type of field. However, I will say that there will be so many carbonyls, so many of them, that you are going to be drinking carbonyls, eating carbonyls, dreaming about carbonyls, maybe making out with a carbonyl in a theater. Who knows what you'll be doing with carbonyls by the time these lectures are finished. The only thing that I will say is that at the end of this, you will be like, oh, goodness gracious, thank goodness I do not have to listen to another carbonyl lecture in my life, because that's what it will come down to. So, toward the end of the semester, I give you a nice little Christmas package almost in a way, if this is the fall, or in the spring, a nice little summer getaway package for you and your loved one. And you can talk about carbonyls all that you want to talk about. Tell them about all the wonderful things that you have learned in this class. Makes great for holiday seasons. So, I need to talk about carbonyl. And the first question that you're going to have is, what on earth is a carbonyl? Okay, if you've not learned it yet, a carbonyl is a C double bond O structure that is in organic chemistry. Okay, C double bond O, there's tons of them. There's tons of different things that include a C double bond O. And because there's tons of these, folks, it's actually one of the most important functional groups that we have that we discuss in organic. You know, think about the semester so far. We've talked about alcohols. Then we went into benzenes and substituted benzenes and organometallics. And now we're getting into the carbonyl family, and there's tons of them. But they are some of the most important functional groups that's out there. Talk about the human body. Folks, this is where it's at. There's tons of carbonyls that make you work the way that you work every single day. What do I mean by that? Well, the carbonyl family is going to include things like hormones, vitamins, amino acids. There's no such thing as a good one. Proteins, drugs, fake flavorings. The list just goes on and on. If you look at this setup, the way that I've kind of preempted this up, folks, all of this is going to really dabble into the world of biochemistry. We're talking about chemistry at the biological level, which is really how you work the way that you work. Amino acids, proteins, vitamins, hormones, drugs. Folks, it's all connected together. And what it's connected by is through a carbonyl functional group. Now, we've talked about carbonyls somewhat in the past, in some random kind of weird form or another. This C double bond O has always crept up. Here's an example. Do you remember those alcohol reactions that we had back in the early day, back when we were young, budding organic chemists in part number 2? We talked about a C double bond O with an H. Okay, we called this an aldehyde. And remember, we said that, hey, if we have a C to an OH bond and then a double bond to a carbon, this is called an enol because of the double bond and the alcohol group. Well, we said enols were not very stable, and enols will rearrange on itself. And what we will see is a tautomer that begins to be formed, and that double bond shifts up, and the hydrogen switches to that carbon. And this will go back and forth, back and forth, back and forth, back and forth, and we call that a tautomer. Folks, during this time, we introduced this thing called an aldehyde. So if the OH group was at the end of a molecule and a double bond formed through the enol tautomerization, that was an aldehyde functional group. But we also talked about this alcohol group that could be in the middle of a chain. And if that enol tautomer did what it was supposed to do, then the C double bond O would go in the middle. And if there wasn't a hydrogen on the left or the right, this was called a ketone. Folks, these are two carbonyl classifications that you already know at this point. We've touched on them very briefly, but we at least did their structures, we did their functional groups, we gave them a name, so already we have a head start in the carbonyl family through this concept of aldehydes and ketones, and that was because of the alcohol reactions that we learned what might seem like ages and ages ago. So aldehydes and ketones are going to be important. They're going to show up in this lecture series. You might as well get ready for them. They're going to come your way, and they're going to make themselves known. However, we also talked about another carbonyl. Remember the C double bond O with like a chlorine after it, and then just a random R group that's over here to the right-hand side. Well, where did we see something like this? That is a carbonyl, and what we called this was an acyl group. Remember that? This was an acyl chloride. And we talked about acyl chlorides when we discussed Friedel-Crafts acylation. Well, that was in the benzene reactions. We had another carbonyl that showed up. I did not focus on the carbonyl. The reason is because the focus wasn't the carbonyl. The focus was the benzene ring during that time. Well, this is another functional group that we can talk about, that we can pull out of the bushes from ages and ages of lecture material ago, and we can talk about this type of carbonyl that we have already seen. So Friedel-Crafts acylation was in the benzene ring family. Remember what that used? That required AlCl3 and a little bit of water. Okay. Well, we also had an acyl group that could also be attached to a aromatic ring, like a benzene. And we said that this was just abbreviated as AR. That was another different type of carbonyl, very similar to the acyl chloride, but this time it's attached to an aromatic. Again, another carbonyl, something else that we've already talked about. Not an issue, but now is the time that we focus on the C double bond O characteristic. That is what we're getting ready to do in this lecture series. All right, so before we go further, I need to kind of give you a path here, a roadmap of what we're going to be talking about throughout the next couple of weeks due to the carbonyls. We're going to have something called Class 1 Carbonyls, or Type I. You pick it. I don't care what you call it. And then we're going to have something called Class 2. Oh, who would have thought? Class 1 and Class 2. So there's a big difference between these two classes, and this is how the lecture material is basically going to be fleshed out. We're going to focus on Class 1 first. All of the carbonyls that are involved in Class 1, we will go through the run-of-the-mill scheme that we've always done with each other, especially if you had me in 251. We're going to go through the functional group, how to identify the functional group, how to name the functional group, and how to react with the functional group. That is the order that we'll do this. And then we'll go to Class 2. So Class 2 also involves carbonyl. It's just a different type of reaction scheme that they do. That's why we divide them up into two classes. So all of the carbonyls that are in class 2 react a similar way, and we'll do the same thing. We'll talk about the functional group, we'll identify the functional group, we'll get comfortable with it first, we'll talk about how to name those with that functional group, and then how to react those with that functional group. Then finally, what we'll do at the very end is I'm going to make something that I call class 3. And this is just really a hodgepodge of things that don't quite fit into class 1 or class 2, or maybe special topics that we need to talk about as far as carbonyl family is concerned. So here's the plan. Right there, right in front of you. It looks very easy, doesn't it? I mean, class 1, we'll talk, we'll name, we react. Class 2, we'll talk, we'll name, we'll react. And then class 3, it's just all of this random hodgepodgey things. Pff, I got this, right? No, you won't. And I'm saying that because I'm trying to warn you of what's to come. You've got to be ready for it. If you're not going to be ready for this, folks, we're wasting our time. And the reason that I say that is because there are tons. There's tons of these functional groups, which means tons of reactions are getting ready to be slapped all over the pieces of paper as we muddy through this field of carbonyl. For example, let's talk about class 1. I told you, this was the first class that we're going to talk about. We're going to identify them, we're going to name them, we're going to react with them. Okay, well, what's involved in class 1? Something called carboxylic acids. Oh, well, we learned about that in Chemistry 251. We talked about acid and base chemistry. Carboxylic acids were part of that lecture series, and carboxylic acids had a pKa of around a 4, so I know when it behaves as an acid. Okay, great, good for you. But at no point did we ever talk about how to name them. Okay, that means IUPAC name and common name. All right, then we have something called Acyl Halides. Remember, C double bond O with a chlorine on it. That's an acyl halide. It's an acyl chloride. Okay, well, that's something that we've seen before, but we now are going to talk about how to name it IUPAC, how to name it common name, how to do reactions with it. Then we're going to talk about acid anhydrides. Acid anhydrides, we've not seen that before. No, you've not. That's a new functional group. We've got to common name it, we've got to IUPAC name it, we've got to react with it. Next, esters. Esters is another carbonyl that you might not be comfortable with. We need to IUPAC it, we need to common name it, we need to react with it. Next one, amides. Amides, that's a carbonyl. Amine is what it looks like, but there's a weird little D instead of an N there. Well, that means that it probably does have a nitrogen with it as well, and it does. So amides are carbonyl groups that we need to IUPAC, we need a common name, we need to react with them. That's just class 1. We're going to be talking about 5 different sets of nomenclature rules, one for each functional group family. And then we're going to do the same 5 all over again using common names. And then we're going to take each one of these and learn how to react with them. Guys, this is just really in the first week or two. That's it. And then there's a class 2. And then there's a class 3. You got it. Now you see the problems with the carbonyl family. Again, tons. Good news though. They group them all together for a reason. And the reason that they group them the way that they do is because they do show similar characteristics. The IUPAC nomenclature is similar. The reaction schemes, they are similar, which kind of makes this make sense. So if class 1 is what we're going to focus on first, what about the reaction scheme? They all have something in common. And these contain a group that can be replaced by another group. You're dating. significant other. Things are going along great. You go to a bar, you have a bad night, and then you decide to replace the partner. You replace it with a new incoming group that came through the front door. Well, that means that we are working with nucleophiles again, folks. So we go back to the same old story of electrophile and nucleophile and substitution reactions. That's how we ended Chemistry 251, or that's how we should have ended Chemistry 251. So that must be different than Class 2, and it is. And I'm not going to go into Class 2 right now. We already have enough. We already have enough on our buffet plate of carbonyls. So, Class 1, carboxylic acids, acyl halides, acid anhydrides, esters, amides, and all of those will undergo reactions that are going to be replaced by a nucleophile. Remember, nucleophile is nucleo-loving, and that really means neutral-loving, which probably is something that carries a negative charge. I mean, that's something that we've always seen every single time that we have talked about a nucleophile. The same kind of thing happens here. All right, let's talk about the functional groups. Let's just get familiar with them. We'll do this all at one time. So I've got a carbonyl. There it is, C double bond O. And that carbonyl is attached to a main chain. It could be a carbon chain, whatever I want it to be. It doesn't matter. And off of that carbon, we have an OH. One of our first carbonyls that we've ever discussed together, and that was in Chemistry 251. And this is called a carboxylic acid. All right, so there's your functional group number 1 that you're going to have to remember. This is something that we're going to have to get used to. And I should be able to pick out these organic structures. I should be able to quickly identify this grouping as a carboxylic acid grouping. So there's group number 1. All right, let's do this again. Main chain. Off of this is a carbon double bond O. And then, let's say on the other side of this carbon, there is an oxygen that is then paired with something else. I don't really care what that something else is. You should not care what that something else is right now. So that C double bond O group, that is the focus. This is what we call an ester. All right, so if we've talked about infrared spectroscopy at this time, this is a functional group that was out there that we should have been comfortable with. This is just a review, right? Ester. If we haven't talked about infrared spectroscopy, depending on how the lectures fall, then this is something that's going to creep up again when we get to that point. All of these functional groups will creep up. All right, so there's functional group number 2. There's my ester. Next, let's say there's a carbonyl with an oxygen and another carbonyl. So a random group here and a random group there. This grouping, folks, a C double bond O, C double bond O, that is what we call the acid anhydride. That is another carbonyl of type 1, and we better get used to that one as well. So there is number 3 on our buffet plate. Next are the acyl halides. All right, so if we have a random group with a chlorine or with a bromine, I can call these acyl halides if it's an X. Sometimes they do that. They do that crazy little abbreviation of an X, and they're supposed to, say, hey, you remember back in Chemistry 251, when X is used, that's a halogen. It can be chlorine or bromine or iodine or fluorine or any of the other halogens. Okay, well, if it's an acyl halide, they'll put a random X that's present. But we can also call this an acyl chloride if chlorine is there, or an acyl bromide if bromine is there. It doesn't really matter. So there is number 4. Number 5 that we need to talk about, that we've listed before in our previous list, was an amide. So this is a C double bond O, random alkyl group. It can be anything that it wants to be. And over on this side, though, we will have a nitrogen-containing species. Okay, now, the reason that I said that is because it doesn't have to be NH2. This is the simplest amide. But nitrogen's kind of funny because option number 1 is an NH2 that's there, but I can replace that hydrogen with a carbon chain. It's still classified as an amide. Or I can replace both of those hydrogens with carbon chains, and they do not have to be the same carbon chain. They can be different. There's just 2 carbon chains that are on it. And that's also called an amide. Now, as you can imagine, each one of those will have its own nomenclature system as well, and we've got to learn how to get through this and how to name them all. So again, group 2, we're not going to talk about right now. We're bypassing that up. Who cares about group 2? Just pretend like it doesn't even exist. Trust me, by the end of this block alone, you'll please do not exist. But you know what's going to come. So this is kind of the order that we're going to go through. We're going to talk about how to name these first before we go into the reaction schemes. So we're going to start off with carboxylic acids. That's where we're going to hit to first. And carboxylic acids, folks, they are one of the easiest to names. And let me kind of show you why. All right. So what you do, the rule is going to say, find the longest carbon chain that includes the functional group. Okay, that's the key word. It's always been the key word. Nothing has changed here. Even in Chemistry 251, nothing has changed with this very first rule. The longest carbon chain, including the group. That's what we're after. All right, then we're going to name it. We're going to name that long chain. You name that long chain. I know you can do it. And then when we name it, we're going to the E at the end, because it's probably going to end up with propane, hexane, octane. The E at the end is going to get dropped. And then we are going to replace that E with a oic acid as the name. Bear with me. We'll do a few examples, and you'll see where this is going. And that's it. As far as the parent name is concerned, that is it. Now, the question that I always get from people, and you'll kind of hear this and you'll be like, well, why is that a question? But sometimes this works and sometimes it doesn't. Sometimes we'll include it, sometimes that we don't. So if I have a C double bond O with an OH, there's a carboxylic acid, and there's a carbon and a carbon that's here. The question is, do I count that as part of my long chain? And the answer is, yeah, you do. You do. You got to. So we do include the carbon that's involved in the double bond O. Now, again, you're looking at that and saying, well, I wouldn't expect anything otherwise. Good. Right now, you would not. But you haven't really gotten deep into the world of carbonyl. That's why you're saying that now. So how would we name this? Very simple little carboxylic acid right here. Well, I used the rules. Number 1, find the longest carbon chain including the group. All right, so here's carbon number 1, carbon number 2, carbon number 3. We'll call this propane. There you go. And then step number 2 says erase that E. There it goes. And we're left with propane. And then it says change that to oic acid. And there you go. There's the name of the carboxylic acid. It even tells me that in the name. It's a carboxylic acid. I know that because it ends in ic acid. So the name of this carboxylic is propanoic acid. There you go. That is a simple, clean, little molecule that's not going to cause you any trouble. It's almost so cute, you want to just pat its head and bring it home. So propanoic acid. Okay, well, what if we had like C double bond OOH with another carbon? How would we name that? The same. That's a 2-carbon system. 1, 2. That's it. Okay, so ethane, ETHANE. And the directions tell me, erase the E and add oic acid. And that is called ethanoic acid. Huh. Is this complicated or is this kind of easy? Well, let's keep going. 1, 2, 3, 4, 5. Name it. 1, 2, 3, 4, 5. So this is a pentane. I learned that from Chemistry 251 because I had a great teacher. And then we'll erase the E. And then we'll replace that with oic acid as the name. Pentanoic acid. Okay, so I think I kind of get it now. Methanoic acid, ethanoic acid, propanoic acid, butanoic acid, pentanoic acid, hexanoic acid, heptanoic acid, octanoic acid, nonanoic acid, decanoic acid. There you go. There's the first 10, folks. That's all there is to it. You can make a little rhyme, make $1 million, release it as a song. The radio will eat it up. Now the question is, what if I have a double bond in it? Oh, I have a double bond. What if this example problem said, Tracy, draw the structure of propanoic acid? Oh, look at there. What do they want me to do? Well, ene represents a double bond, doesn't it? Yeah, that IUPAC rule doesn't go away. So propanoic. Now I've got to be really careful. Propanoic, propanoic. Use your words. I mean, that's what the kindergarten teacher always said, right? Use your words. I was going to slap her. So propanoic is prop, which is 3. There we go. Oic acid, oic, is double bond OOH. There is propanoic, propanoic. Well, where's the double bond? It doesn't give me a number. Okay, well, most of the time, if it doesn't give me a number, then that means it's on carbon number 1. All right, so here's carbon number 1. But I can't put a double bond right there. Well, why not? Well, count them. 1, 2 at the top, 1 to the left, and 1 to the right. There's a total of 4. It can't have a 5th bond. So we go on down to the next carbon, and that carbon could have a double bond. There's only one option for me to put a double bond here, folks. It cannot go between carbon 1 and carbon 2 because the first carbon already is maxed. Sorry, can't put it there. So propanoic, the reason that they don't give you a number is because there's only one option, and that option is between carbon 2 and 3. That's it. There's where my double bond is going to go. Well, if I want it to be proper, I could put a 2 right there. That 2 means that that is where the ene group is going to go. Carboxylic acids, they always have to happen at the end, right? It always has to end up with C double bond O with an OH on that side. Nothing more, nothing less. All right, so let's do one more before we stop this video. And this one is trans 2-butanoic acid. Oh no, trans and cis? That was like chemistry 251 stuff. Why do I have to go back and talk about it again? Because that is what happens with the carbonyls. I always told you organic is the foundation class. You gotta learn the basics and you gotta keep the basics in order to do well. So butanoic, but 4, 1, 2, 3, 4, oik, acid, double bond OOH. I know it has to be that. Okay, so the 2 here basically is telling me, hello, that is where the double bond needs to go. So carbon number 1 and carbon number 2, I'll see the double bond right there. But it gives me trans. I've got to show it trans, folks. I can't just leave it like this. That doesn't mean anything. The problem wants me to go further. It wants me to go back and remember what trans and cis was all about. So I need to redraw this, and I need to put a focus on the 2 carbons involved in the double bond. You thought that went away, didn't you? It's back. So on the left-hand carbon, okay, I'm going to color this one blue. There's the blue carbon. There's the blue carbon. So the one to the left looks like there's just a carbon that's there. Okay, well, what's the 4th bond? There's 3 that's drawn. What's the 4th? Well, the 4th is to a hydrogen. All right, so a carbon is going to go there. And then that 4th bond is going to be a hydrogen. It didn't matter if I put it at the top or the bottom. I just need to make sure that the end result is trans. That's all that I need to do. All right, so I got to start somewhere. That's where I'll start. Now, the carbon on the right-hand side. That carbon on the right-hand side, we're talking about this one. Okay, that's this carbon. Well, that carbon looks to me like it is connected to a C double bond OOH. There's the group. But where's that 4th bond? Well, again, that 4th bond is a hydrogen. Okay, now maybe I remember what trans meant. Trans means opposite sides, and opposite sides refer to the hydrogens. So that means I have to draw this structure to make sure hydrogen's on opposite ends. So there's the trans form, which means that my carbon double bond OOH is going to happen down here at the very bottom. Now, notice what I did there. C double bond OOH. It looks like a little squeezy to me. And the reason that I say that is because I had to make effort not to get that too big because it kind of mushes in with the rest of the molecule. Well, there's another way that we can represent C double bond OOH. And we just write it straight out. COOH. It means the same thing. It is a shorthanded form of the carboxylic acid group, and this is a condensed form that makes these structures a little bit better. So C double bond OOH is also known as COOH. And look, these 2 oxygens right there in the center, folks, it sees you. And it knows that it's getting ready to give you problems. And that's why it's very happy. All right, so there's the carboxylic acid. That's where this video will stop. And the next one will pick up from here.